All right, I want to share with you the notes for lesson 1-3. So bear with me and stay focused. I'll zoom in so you can see it better. So here we go. In geometry, a postulate is a statement that is assumed to be true based on basic geometric principles. An example of a postulate is the statement, through any 2 points is exactly one line. A long time ago, postulates were the ideas that were thought to be so obviously true they did not require proof. A theorem, however, is a mathematical statement that can and must be proven to be true. Now, you've heard the word theorem before when you learned about the Pythagorean theorem. Much of your future work in geometry will involve learning different theorems and proving they are true. We're not going to do as much as maybe some other courses of geometry with theorems, but we definitely will look at some of them. So let's continue. Most of the geometry concepts and theorems that are learned in high school today were first discovered and proved by mathematicians such as Euclid thousands of years ago. Given that these geometry concepts and theorems have been known to be true for thousands of years, why is it important? Why is it important that you learn how to prove them for yourself? And what does it mean to prove something? In the past, you've often been asked to justify your answer or explain your reasoning. This is because it is important to be able to show your thinking to others so that ideally they can follow it and agree that you must be right. A proof is just a formal way of justifying your answer. In a proof, your goal is to use given information and facts that everyone agrees are true in order to show that a new statement must also be true. So we're not going to do so much with proving. We'll talk about justifying and explaining, but we're not going to do formal proofs in our geometry class. But we do want to understand the vocabulary about postulates. That's going to be important for us. So to finish up, in geometry, axiom and postulate are essentially interchangeable. We're going to use the word postulate a lot. In antiquity, they referred to propositions that were obviously true and only had to be stated and not proven. In modern mathematics, there is no longer an assumption that axioms are obviously true. Axioms are merely background assumptions we make. The best analogy I know, so you can understand this, is that axioms are the rules of the game, or we can say the postulates are the rules of the game. So that's important. So postulates and axioms are basically the same thing, and they're basically the rules of the game of geometry. In Euclid's geometry, the main axioms, postulates, are the following. So these are the main rules of the game that we're going to be looking at. There'll be others, but these are the main ones. Number one, given any two distinct points, there is a line that contains them. Number two, any line segment can be extended to an infinite line. Number three, given a point and a radius, there is a circle with the center in that point and that radius. Four, all right angles are equal to one another. And number five, if a straight line falling on two straight lines makes the interior angles on the same side less than two right angles, the two straight lines, if produced indefinitely, meet on that side on which are the angles less than the two right angles. Whoa, that's called the parallel postulate. We're not worried about that right now. But these are examples of postulates, the rules for the game. A lot of them seem pretty obvious, and that's what postulates are. They're obvious rules of the game. And when you hear about theorems, a theorem is a logical consequence of the rules, of the postulates and axioms. In geometry, the propositions are all theorems. They are derived using the axioms and the valid rules. A corollary, another vocab word, is a theorem that's usually considered an easy consequence of another theorem. What is or is not a corollary is entirely subjective. Sometimes what an author thinks is a corollary is deemed more important than the corresponding theorem. Now, out of all that information, the key for us is, like I said here, this part. It's about the axioms and the postulates. We're going to refer to them mostly as postulates. Okay. What is a postulate? Think of it as the rules of the game for geometry. So let's take a look at a few of those in this lesson 3.